Today, I'll introduce VLM², a vision language model with persistent memory for long-horizon spatial reasoning. Spatial reasoning goes beyond recognizing an object. It means understanding where it is, how far away it is, how it relates to other objects, and how an agent should act. These skills fall into three groups: perception for localization and memory, action for navigation and interaction, and modeling for building a stable representation of the world. That is why spatial reasoning supports everything from visual question answering and video understanding to navigation, scene modeling, and robotic manipulation. Language models are strong in the symbolic world, but physical space involves distance, direction, and changing viewpoints. A 2D image is only a projection, while the model must recover a stable 3D structure. Traditional systems use point clouds or depth maps, which provide strong geometry, but they depend on additional sensors, such as LiDAR, and 3D data remains scarce and computationally expensive. Recent methods extract geometric cues from ordinary video using 3D foundation models. This removes the need for real point clouds, but simply combining 2D semantics with 3D features still creates misalignment. This leaves two gaps. The model may recognize a chair without grounding it consistently in space, and its context window may overwrite earlier observations instead of preserving them as persistent memory. When the camera moves, the same chair can look very different. The model still recognizes the category, but may treat the chair as a new object and lose spatial consistency across viewpoints. Long videos create a second failure. After entering a new room, earlier objects may fall outside the context window, so counting and cross-scene reasoning no longer have reliable evidence. VLM² tackles both failures. Think of it as giving the model goggles and a backpack. The goggles provide view-consistent 3D perception, while the backpack preserves short and long-term information about objects that are no longer visible. The pipeline has three stages. A 2D encoder extracts semantic features, while the Pi3 foundation model provides geometry and viewpoint cues. Two alignment modules combine them into a view-consistent 3D representation. A dual memory system then retrieves recent and earlier observations, and the language model uses this memory to answer the spatial question. The first module has two key ideas. Adaptive position injection uses a learned gate to keep reliable 3D coordinates and suppress noisy predictions. Viewpoint-aware geometry alignment adds view tokens to geometry tokens, distinguishing different camera angles. Cross-attention then fuses both streams into a stable 3D, aware representation. The second module separates short and long-term memory. Working memory is a sliding window over recent context. Episodic memory is a fixed capacity bank for earlier, important observations. A learned gate combines them, while similarity-based updates prevent redundant storage and keep computation bounded as the video grows. On VSI Bench, VLM² reaches an average score of 68.8, outperforming VLM², by 7.9 points. The gains are especially large in route planning, at 28.2 points, and absolute distance, at 10.2 points, evidence for both memory and 3D awareness. On ScanQA, VLM² achieves a CIDR score of 105.5, 13.7 points above the next best video-only model. It also scores 60.4 on Scan Quadricorda 3D. Using video alone, it matches or approaches methods that require additional point cloud or depth inputs. The ablation study shows that both components matter. Adding the 3D aware representation raises the average from 55.2 to 63.8. Adding the full dual memory module brings it to 67.8. In short, seeing accurately and remembering persistently provide complementary gains. Looking ahead, this work could extend to dynamic egocentric vision, scalable 3D representations, embodied agents that generalize to new environments, and fusion with LiDAR, radar, event cameras, and other sensors. In summary, VLM² helps vision language models not only see space, but remember it over time. Thanks for watching.